Good afternoon, everyone. My name is Andrew Parker, and I'm a sales manager for the East Coast for Fortress Power. To give you guys a little bit of background about me, I've been installing solar in the field for about 2 or 3 years, so I kind of know how the process goes, what it's like to wake up at 5 o'clock in the morning, put your boots on, get your hands dirty. I kind of know what the job entails. And also regarding Fortress, I've helped package the batteries, ship the batteries, and general transport as well. I know different methods of transporting on the job and kind of how to maneuver them. So kind of moving forward, we do expect a big uptick in energy storage this year. Over this webinar, we're going to cover frequently asked questions, such as where the market's going, why install energy storage, as well as how lithium iron phosphate is the best chemistry for the job. So now I'll pass it on to Jing, and she will dive more in depth in it.
Hello, everyone. Welcome. Let's get started. So my name's Jing Yu. I'm the managing director at Fortress Power. And I've been in solar for many, many years. It's been quite a while, but enjoyed every day. I actually have my electrical engineer degree and also Master of Business Administration degree. And, I received both degrees in Germany. So that's, as you know, Germany is always ahead of curve in terms of solar, even solar plus storage. So today I'm going to cover why we are talking about energy storage here today. And we're also going to introduce about, our company, the product line that we offer. Then we're going to dive into the battery technology comparison to bring you up to date, what's the best lithium chemistry for energy storage application and how they compare with the lead-acid batteries. Then we're going to be introducing 2 different methods to add battery storage to your PV array based on the existing PV array or new PV array. We're also going to introduce 2 different types of inverters available in the market. At the end, we're going to briefly touch about how to design PV plus storage for battery backup. We do also offer, a separate section and dive more in depth of design and installation. And that will be that seminar will be held in 3 weeks. And we will send you an email about that one as well. So why energy storage? Now, if you look at the traditional PV grid tie systems, right, we have a few challenges. One is how to balance the generation and consumption. For instance, during the day, you're not home, but your PVs produce the most. And that's in the evening, and when you need when you want to consume your electricity, well, your PV is no longer producing the power. And that actually adds a lot of stress for the grid. So the grid has to absorb a lot of PV production during the peak, in the daylight, and the evening have to supply the power. So storage is really going to help that solve that issue. And second is the traditional PV inverter has to shut off when the grid goes off. So that's also a big challenge. Now, in some areas, you might not be able to feed back to the grid like Arizona and Hawaii. Then you will, then your PV, you have to add a storage because just by put up PV systems, it wouldn't work. And that's why storage come into place, that you can store the power when you don't need it. And in the evening, you can, discharge your battery and to power your home. So that really solves the needs and demand problems that PV has created for the grid. By doing so, that also improves the grid resilience. As you may know, that utilities are now also very proactive involved in the energy storage. Either, they also invest money in research, or they also invest money in doing a lot of big utility scale projects. And then having storage, then you can also island your systems. When the grid goes off, then your PV and storage can basically self-supplying your home. And this is just, a very nice way to describe how technology evolves. I'm sure that, maybe some of you guys had an old Motorola phone before. It's heavy and the battery wouldn't last long. Now with the lithium technology, you can actually, just put in your smartphone and then it lasts for days to make things very easy. Let's also take a look at how the market evolving globally. As you can see that from this is really a nice growth chart, and almost all the countries, continentals, going to have a nice growth rate. In 2019, we had about just over 3 gigawatts new installed energy storage capacity, but then in 2040, we're looking to achieve almost to 1 terawatt, so like 1,000, gigawatts. So it's a tremendous growth opportunity for all the markets. Let's take a look into the U.S. market. How is the growth pattern look like? In this year, we are about, close to 500 gigawatts. Again, we're still waiting for the GTM research to publish the latest data, and this is what they estimated in last quarter. And the number is gonna climb up to 5.4 gigawatts. In terms of different sections, the front of meter is basically utility scale projects. Those are still gonna dominate the market. Well, let's put another way. In 2019, it's almost equal. Like the front of meter is about 50%. But again, that segment is gonna grow very quickly because a lot of investment is gonna go into that space. But if you look into the residential and non-residential, basically commercial and nonprofit, it's a very steady growth, and it's also going to constitute about 30% of the total market. And I think those are a lot of folks like you are participating in that segment. So we will be continuing seeing tremendous growth here in the States. And so I forgot to mention, actually, U.S. is considered to be the number 1 or number 2, depends on which year it's going to be, the big energy storage market. Down in the South American market, it's also going to have a nice steady growth annually, 30% or more. Here, the utility is also dominant because the monopoly of a lot of utilities, local utilities. But if you look into the remote power, residential, commercial, industrial, that growth is also very steady, very nice. Now, what can energy storage do for you and your clients? Traditionally, it started with off-grid application, and then it's moved up to battery backup application. Then we've seen also some areas deploy as a self-supply. In California, time of use is a big application. And also for commercial clients, it can also help you to reduce your demand charge, which is the kW charge. We're going to talk through each individual application briefly. Now, this is a traditional off-grid. I'm sure a lot of you are familiar. There's no grid, and you have your PV, your hybrid inverter, your battery, and then you to power your entire home. And you might also want to add a generator, just in case if you live in the area that like here in Northeast, you might have cloudy days for a while, and then have a generator as a backup if needed. Now, if you are, I think the most part of the country that the grid is, the utility is going to allow you to feed back excessive power from the PV. So you can set up your systems, during the day when it's connected to the grid, you can actually push the excessive PV production, feed back to the grid, get on net metering. And then when, in case of the power outage, then it will disconnect it from the grid, and then it will act like an off-grid system to power your essential load, like important circuits. You certainly can also do the whole house backup if you have enough budget for that, but most of cases, people will just back up those essential loads. When you are living in Hawaii, Arizona, or in the many Caribbean countries, it really doesn't make, either you can't feed the PV production back to the grid, or it does not make any sense for you to feed excessive power back to the grid because utility will not give you anything. In that cases, you can design your system that your PV and storage is going to be supplying your home load, and you're going to use actually the grid as a backup. So, for instance, during the day, the PV power the home circuit and charge the battery, and in the evening, then the battery will be discharged to power your home circuit. And then if, late evening, the battery is, goes low, the grid can take over to power your home load. And next day, the same cycle is going to happen again. Well, California, as we know that this is, an area that you're going to have a very big price difference between the peak time and off-peak. So peak time somewhere between 4 to 9 p.m. and your electricity price can go as high as, like 60 cents. And off-peak could be low as, as 17 cents or 20 cents. So in that case, then you can add in a storage. You charge the battery, basically, off-peak, and then use the battery during the peak period. You can, if you have a solar, of course, it's better. It's clean energy. You also get a 26% tax credit. If you don't use solar, you can also just use the battery and to power that, 4 or 5 hours time window. And if the grid goes off, you still can use your energy storage to be on, battery backup option as well. Now, for commercial clients here, we've been seeing a few cases here in New York, or helped a few customers in New York to start up systems here, especially in New York City, that where you pay very high kW charge. It could be as high as, even over 50% of your electrical bill will be a kW charge. In that case, by solar itself will not solve the problem, or then you can have a battery backup system to shape those peak charges, bring down the baseline. You can also work without work without solar. But again, with the solar, you get a 26% ITC, you get a depreciation, and it really economically makes a lot of sense. And we've been seeing also some inquiries from California, some other part of the country, because there is a lot of business are actually being charged by KW, the demand charge, and based on analysis that we did, if that KW charges above $15-16, that's where you start to have make sense to take a look into the and size up and see how the cash flow look like for your commercial clients. So that's about the different applications of energy storage. I know there's a lot of information. We're going to also provide you the slide later on, and of course you are welcome to contact us with any questions. Now, Fortress Power, we are a lithium battery manufacturer. We're based in Southampton, Pennsylvania. It's about 35 minutes north of Philadelphia, one of the oldest city in the U.S. We have 30,000 square foot facility where we do a lot of R&D testing. Our sales and the service team are based here. We ship a lot of product out of this facility as well. We do have also logistics centers in California and Florida, where we serve, clients in the West Coast and clients down in the South Latin American market. We have about 45 megawatt hour installed capacity worldwide. And also, we are very proud to be the only battery manufacturer supplier for a local railway company here. And it's, as you can imagine, railway, the safety is the number one, and, having reliable solution, that's very critical for them. Here's our manufacturing facility. They're based in Shenzhen, China. If any of you been in China, Shenzhen is considered to be Silicon Valley in the east. A lot of smart people, a lot of engineers, IT or power electronic engineers. The facility is ISO and Authorized certified. It has been starting producing lithium iron phosphate batteries since 2008. So it is a proven technology. The lithium ion we're going to talk about later, where the tests are focused on is really starting to be, commercialized in 2014, 2015. It mainly supply over 90% of capacity goes to automotive. I think the demand of automotive really, propelled the cost reduction of lithium battery. And then that's why, we're here today to actually benefit from that. We have about a 1 gigawatt hour production capacity in this facility here. Here are the 3 product lines that we offer. The biggest unit we offer is 18.5. That's 360 amp hour. And then we also offer 10 kilowatt hour and 5 kilowatt hour. Here, this is a new product line I want to briefly mention. It's going to be available in Q2 2020. There's a few new features goes with that product line. It has, SD card for data storage. It will be able to go back to see how the batteries are being used, and building Wi-Fi remote monitoring. We're working on the remote monitoring options. The reason we designed this product is mainly because this is really flexible to, you can do wall mounting if you're in a flooded area, you want to put on a wall, or you want to just stand on the floor standing. That works well too. Or you can put in a server rack, can stack them up. So it's very flexible. That's why we call it like eFlex. Here are some technical specifications. I'm not going to go through them here, because of time. Basically, it's a 48 volts battery. So if you just want to get a battery and you're looking for, inverter or charge controller, make sure you're looking for 48 volts DC input charge controller inverter. In terms of parallel stacking, the eVault can go up to 12, so you can go up to 222 kilowatt hour. That's good to cover, some commercial projects that you have. The eFlex can stack up to, actually, I think here's the typing error, should be 15. And the 10 and the 5 are, stacked 2 or 3 of them. And I'm going to explain why is that in the next slide. The eVault and eFlex can have open loop communication with inverters. The 10 and 5, you will be setting up the parameters in the charge controller and inverter, and then by that way, the inverter charge controller can, manage charging, discharging of the battery. Here in Canada and U.S., we are starting with 10 years warranty. Outside the U.S., we already start with 5 years, but you can extend it. And the reason of doing that is because of some of the markets we do not have enough data to know that what kind of how the system is going to be installed in somebody's home, what kind of environment is that. So that's why we start with 5. But again, we can extend it, and there's warranty registration form you can fill out and sign back. We guarantee 6,000 cycles at 80% step-up discharge. That's across all the markets. Now, I'm going to talk about a battery management system. As you may know, in a lithium battery, there's 2 main components. It's battery cell and battery management systems. And when we talk about the battery management systems, if you look at the products available on the market, there's also mainly 2 types of them. Most of them use actually MOSFET-based battery management systems. Here's seeing that we have, it's reached our maximum. That's it. Let me close this one here. So the MOSFET battery management systems, it's a circle board with a built-in MOSFET. It does offer overcharging, deep discharging protection, overheat and low temperature protection, over current protection, short circuits and open circuits protection. And some of them have cell monitoring and balancing, some don't. The 5 and 10 we offer do have that cell monitoring and balancing ability, but I know that a lot on the market probably do not have that cell monitoring balancing, which is critical for longevity of the battery bank. Just like, solar panels, you want to make sure they're operating at, same amperage and voltage, and the same with the battery cell that line in serial and in parallel inside of a battery bank. The eVault and eFlex, we use actually contact-based battery management system. So you have, of course, you have your circuit board, then you have also solid-state relay that we put there and the fuse as well. So it's more robust and can handle more amperage. In addition to all the protection we just talked about, it can also, has a basically closed loop communication with inverter. So there's, protocol. Once the inverter or the battery has the protocol, same protocol, and then the battery management systems can report the state of charge to the inverters, and it's just much more accurate way by doing so, especially critical for big systems like eVault. If you stack, many of them, then they have this closed loop communication where it works, better. And you can also pair more units because the batteries you put in parallel, there's also RG45 cables. You can connect with them, create a master and slave relations, and then you'll be able to monitor them and make sure they all work in the same level. That's why the eVault and eFlex, that we allow you to parallel more units. The 5 and 10 is limited by 2 or 3. The 5 and 10 we use a cylindrical cells, and the eVault and eFlex we use prismatic cells as well. And it's because again it's a big system. It's designed for handle more current for big applications. So it is the way it's constructed is much more robust. But the 5 and 10 are perfect applications, solution for some of your small projects as well. So it works, well. We have a lot of that systems deployed. The eVault 18.5 has also local LCD display that be able to provide you the voltage, the SOC, and charging power. That's very favorable for clients that are not able to access to phone apps, prefer have local monitoring, and also it shows those safety features too. So for instance, if there's battery voltage gets too high, then the circles here are going to get shown as a red, give you a local diagnostic. There are many different lithium chemistries available on the market. So widely commercialized are mainly 3, the lithium ferro or iron phosphate. The other one is, the nickel manganese cobalt, deployed by Tesla, LG Chem, Panasonic. And then you have also lithium polymer. Those are mainly for consumer products. Why we choose the lithium iron phosphate, or even called LiFePO? It's the same product we talk about. It's safe because it does not have cobalt. The cobalt is a very temperature volatile element. So if you operate outside of that window, and if the BMS does not shut it off, then you have a likelihood of thermal runaway or even fire catching. Also, because we do not have cobalt, so it can be fully recycled, which is very important because we are in renewable energy. We want to make the earth to be a much better place for the next generation. It has very good thermal stability, and also it delivers at least twice as many cycles as other chemistries like lithium ion or lithium polymer. It degrades slower, that's why it offers more cycles. The only disadvantage is it is a little bit heavier. It requires about 20-30% more space than the other 2 chemistries. But again, that's more critical for automotive because you want to put as many battery banks as possible in a limited space. But then you come at a cost of less cycles and also, poor thermal stability. For energy storage application that we've been seeing more and more solar experts that are moving towards to lithium iron phosphate because it's safer. So you don't have to worry about, and you can sleep well in the evening. Here's a video. You can go online, search typing LFP versus NMC nail test video, and you'll be surprised how quickly that NMC cell will catch fire once the nail penetrates through, while the lithium iron phosphate really nothing happens besides you see a little bit of smoke. That's it. Now, what's the impact on the battery's lifespan? So there's mainly three factors: charging, discharging rate. Idea-wise, you want the battery to be charged, discharged less than 0.5 C. So just give you an example, like 200 amp hour, the 1 C will be 200, and the 0.5 C will be 100. So basically, you want to discharge battery, with 100 amps or less. That's good to prolong your lifespan. And the other two important factors are temperature. Now, this is a typical graphic of how LFP chemistry is going to react to the temperature. The 25 degree, 77 Fahrenheit is the basically, the benchmark here. And as you can see on the high temperature end, that LFP chemistry actually does very well. The capacity is very consistent. Where you start to worry about is when you are using that battery below the freezing temperature. So then you're going to see the capacity is going to drop, and of course, the cycle is going to drop. So we really recommend that you put in indoor, or if you're in a warm area, like, Central Latin American market, you can certainly put an outdoor, but then make sure it's not, exposed direct to the sun. So you have, like a container or under shed. I'm so sorry. I think we are really, there's a lot of more folks who want to join us. So then we actually have occupied. But again, we will be sending out the slides to all the people who register for the webinar. And the third factor is the depth of discharge, just like your phone. So when you let your phone die every time, to zero or even die completely, your battery is going to die much faster. So that's why when below 20%, it shows in the red or orange color to give you a warning, tell you, hey, it's better to charge up your battery. So same here. If you look into it, if you let a LFP battery discharge every time, 100%, you're about, really around 3,000 cycles. If you go 80%, it's about, about 7,000 cycles. And if you do 50%, be very conservative, it can last even more than 10,000 cycles. So we guarantee 6,000 cycles at 80% double discharge. That's mainly for people that need a lot of cycles. And if you just need for backup, and that's happened a few times, a month, or, once, twice a week, something like that, you can set up, 90% of double discharge, get 3,000 cycles. So that's still the battery can last, for more than 10 years or even close to 15 years. Now, many of you maybe read on the news that globally, over 90% of energy storage, are installed with lithium. And why is that? I want to show you a few slides. We're going to start with a number because, again, we're in a renewable energy, efficiency, and the return of investment is still pretty important factors. When you look at the round trip efficiency. So the LFP chemistry, has the best round trip efficiency, 98%. The other lithium batteries about 95%, and flooded AGM as 80 to 88%. Nickel iron is about 65%. Now at 80% DOD, that's expected cycle life you can get from the different chemistries. LFP is number 2. Nickel iron is very good. It's 8,000 cycles. And in terms of the upgrade years, is basically, if you do one cycle a day, how long that battery can last. LFP, you can last 15, 16 years. Flooded AGM, if you let it discharge every time 80%, then you talk about year 2. That's pretty much it is. In reality, I know that a lot of people probably will not go over 50%, and that battery can last, longer. Energy throughput in megawatt hour, that's something I want to explain to you how this number calculated. So you will use your nominal capacity, multiply your double discharge, multiply your efficiency, and multiply your cycle life. So in this case, if you would take, it's a 10 kilowatt hour battery bank. So 10 kilowatt hour multiply 80%, multiply 98%, and multiply 6,000 cycles, you can expect it 47 megawatt hour energy from its life, the battery's lifespan. And the lithium, other two lithium batteries are substantially less, and of course, flooded AGM are much, much less. Nickel iron is, pretty at a similar level. So here is just a suggested retail price here. If you use that cost to divide it by 47 megawatt hour, that's how you're going to get 14 cents with the LFP chemistry. And looking at flattened AGM, it's much more. You talk about 3 or 4 or 5 times more. Nickel iron is pretty good, but nickel iron has the challenge is that it's very bulky, and you need a maintenance, and also the initial investment is very high. So it's really, we don't see too much in the home applications. It's pretty much for large projects or utility scale projects. Now, let's compare the performance from LFP versus lead acid. Now, LFP battery is a 200 amp hour. You really can get 200 amp hours. So it's the nameplate is equal to the actual capacity. While lead acid usually is about 50% of that. So if it's a 200 amp hour, the useful capacity is like 100 amp hour. And also another thing is that the lead acid is also more affected by the discharging rate, the temperature, and double discharge. And also another interesting scenario is if you are living in the south and you need your air conditioning when the power goes off, once you turn that heavy load, the lead acid battery capacity is going to drop dramatically. So if you expect the battery to last for 2 hours, of something 30 minutes later, system shuts off. With the lithium, as long as you're operating under the maximum, discharging rate, the capacity is very consistent. So if it lasts 2 hours, it will last 2 hours. Here is just example showing the space requirements of the 2 different technologies. On the left is AGM. It's a 48 volts, 250 amp hour with a 6 kilowatt hour usable power. On the right, it's a Fortress eVault with a 18.5 kilowatt hour usable capacity. As you can see, it's only like 1/3 of the space that you need, but you actually have more usable capacity. So the overall advantage of LFP chemistry, we talk about safety. It has very high energy throughput, and it lasts very long, and all leads to very low energy cost. And that's important information, the low energy cost. Let's take a look at the differences between AC and DC coupled solutions. I'm sure a lot of you are familiar with that, but I'm sure some of them, would like to know the differences or heard about the term and know the differences. Now, AC coupled system is where you have solar array connected to the PV inverter. It could be microinverter, it could be string inverter, it could be also, optimizer plus string inverter, like a solar H inverter here. It's connect to essential load panel or backup panel. Then you have a hybrid inverter also connect to the essential load panel, as well as to the main panel and to the grid. So the battery is connected on the AC side, as you can see, right? Because the inverter here it's AC power from, DC convert to AC and travels through two inverters, and then the battery is hooked to the AC side. Of course, when the inverter discharging the battery, it will convert either, to the DC or from the DC to AC. So that's called AC coupled systems. Now, it's more popular for existing systems, existing PV array, especially if you have microinverter or, solar H optimizer on back of the solar arrays. Then you would do an AC coupled. It's much simple, easy. But disadvantages are that you have two inverters here. So you have, and there is a multiple conversion. You have DC to AC, now AC to DC, and if you want to discharge the battery again, you have to DC to AC. So there's at least 5% more power loss. The DC coupled solutions that you have PV array that is all connected to charge controller, which is take the DC power to DC convert and charge the battery. And the battery is also connected, of course, to the inverter as well, the hybrid inverter. The hybrid inverter will supply the power to the backup load panel, as well as connect to the main panel and to the grid. It's more favorable for new installation, because then you do not need additional PV inverter, and it's more efficient. And also another thing I want to point out in the AC coupled system, there's one weak point is if the grid goes off and you have your PV inverter and the hybrid inverter work together to power your home load. If the battery is fully charged and then your home consumption is lower than your PV production, now you have a problem, is because that excessive power has no place to go. Then what's going to happen is the hybrid inverter will, through a frequency shift, to shut the PV inverter off. And then 5 minutes later, the PV inverter comes back again, and they shut off again, come back again. So really, DC coupled is much better solution. So even if you have PV, SMA or 4 new string inverters, old string inverters, rather to replace that string inverters with a DC coupled solution. Here's a list of inverters that we'll work with. A lot of well-known brands, and they've been also in the energy storage, market for a while, like Schneider, Outback, Magnum, SMA, Victron. We are a Schneider Outback approved battery partner. Schneider, we are on their literature. There's also integration guidance that are, we have integration guidance with all the those inverters. It's available on our homepage. We are currently establishing closed loop communication with those inverters. Again, it does take a little bit of time because, every integration itself is easy, but all those manufacturers its own priority, especially with Rule 21, phase 1, phase 2, phase 3, really keep them very busy. So a lot of folks of you may use already Schneider inverter in the past. So they have XW Plus and XW Pro. Those are, the main two products now on the market. We like that solution a lot. It's very robust system. You can use for 3-phase. Actually, I think it's for 4 units instead of 3 units. Sorry for that. And you can also do, like in a commercial application as well. So you can do stack multiple of them, each phase, 1, 2, or 3, and then get into a bigger system. It supports, off-grid time of use, load shifting, backup, grid export. You can do AC-DC coupled. If you want to do AC coupling, you just use the inverter. If you want to do DC coupled, then you get the charge controller. So it's flexible that way. It survives. It actually works well in very harsh conditions, like in hot environment, 70 degrees. So for some off-grid applications, it's very important. You can also get a generator thought as an option. Here are some technical information here. The inverter, they have 2 types, 2 sizes actually, and both can surge very nicely, which that's very critical for hybrid inverter. especially if you use for backup, because the surge is really allow you to turn on some, heavy duty equipment. Just give you an example, Tesla has a 5 kW inverter and the surge capacity is 7.5. So it's really not much. So you're going to have a hard time if you're trying to power your geothermal or power your AC units and stuff like that. But the Schneider inverter, has a transformer, and it really can surge nicely, even up to 12 kW for 60 seconds. In terms of storage, you can go up to 510, 18.5 to 222. Has built-in auto transfer relay, can AC couple to many different PV inverters here. This is our correct information here. The front page are incorrect, so need to be revised. Apology for that. Now, we also partner up with SOARC. We do a package deal, a package solution here. The inverter can do single phase or 3-phase. It is very efficient, with a 93% round trip efficiency. All gen is included. You can also do AC/DC coupling with the same unit. It also supports all the functionalities, all the applications that we discussed earlier. So how the inverter works is, you have an on-off. So when you put on solar, it's a 8K continuously draw from the battery and solar. And if it's connected to the grid, then you can, push 12 kW to the backup load panel. So you will choose a 50 amps critical load panel. Has built-in auto transfer, so all the power electronics are in one unit. You can do AC/DC or even can combine together. This is just a graphic to show you how the system is going to install. You have a battery terminal, you have a PV inputs here. Each inverter has 2 MPPTs, so one MPPT manages 2 strings. This is where you connect to the main load panel to the grid, and you have also the this one here is actually go to the backup load panel, and this is going to go to the main panel. And then you have also generator input here, which you can also use to do AC coupling. So if you need string level rapid shutdown, that you can use in a Midnite. It's a pretty robust system here. Basically, how it works, if you push the button here, then the transmitter is going to send, information to lose the power signal. Is going to send information to the receiver, and then each string is going to be disconnected from each other. If you want need a module level rapid shutdown, it works with a Tigo rapid shutdown devices. Both Schneider and SOARC inverters are work with a Midnite and Tigo rapid shutdown devices. Now, a quick touch about how to design battery backup systems. Well, I'm sure you are very familiar of design a PV system. Once you have that, you're gonna, basically talk to your clients, figure out what kind of circuits they want to put on the backup panel. You will take those circuits and build up critical load panel. But again, if your client wishes to back up the whole building, it's doable. It's just very costly. And then based on those circuits you selected, then you can, look up to the total daily consumption. And then, you have clients, maybe most of them maybe 1 day autonomy, so you can select a battery bank. And if they want longer duration, then you can add more battery banks to it. And the last step is if you want to have the client an idea of what they can expect during power outage, you can estimate the daily available power throughout the 12 months and give them an idea so they can, basically adjust their consumption behavior. So here's an example of what you can put to, an 8K inverter. Actually, you can put more. But this home is here that we put about, like 12 circuits there. Power lights, refrigerator, somewhat pumper, electric, that your kitchen outlet, where you can also, charge your phone, you can watch your TV, and even like AC window units, furnace, you can put it there. You can actually put a little bit more because here it only uses about 6.8 kW. Now, we do have an Excel tool that once you select go through a category, select items, the starting wattage and running wattage will come up automatically, and you can put in quantity here. Some of the appliances we have already built in suggested operating hours each day. For instance, like, Energy Star rated refrigerator, your compressor turns on off, so actual operating hours 8. So then it's going to calculate basically each, like circuit or appliance that you're going to use, how much it's going to consume per day. For this particular home, it's about, close to 18 kilowatt hour. And then you can select inverters, and it will show you if it's within the inverter's capacity. So if it's go over the surge power or running wattage, it will give you a red, turn to be red. But again, in reality, you're not going to turn everything at once. So we do this to just be, being safe. This is a 9 kW PV with a 20 kilowatt hour storage capacity. So this is a breakdown by month. Let's focus on June, which has the best production. So average-wise, about a 36 kilowatt hour. So half of that can be charged the battery, and half of that can be used during the day. So your clients can use, them during the day, maybe doing some more. With that, in December, this is a project based in North Carolina. You have about a 20.8 kilowatt hour. So you want to charge the battery first. So during the day, you really want to be conservative and do not use too much. Now you have applications, time of use, self-supplying, demand curtailment. Please, you're welcome to send information to the sales@fortresspower.com. They're one of our engineers, can step in and help you to size the systems or teach you how to size the systems. And we use the different tools and methodologies. That's how you become our dealer. There's a dealer form. You can go online, download it, or we can also email you. You finish up, send it back to us. We confirm it, and then you can, participate on the product and sales training as well and design installation training. So we have staff on here to help you design the systems and train you as well. This is our contact information. So let's see if we have, questions here. Okay, so yeah, we do have it. So I'm gonna have Andrew to read the questions, and I'm gonna answer the questions. Just give us a second. We're gonna pull out the questions here. Okay. Okay, can you see it?
Yep. So we'll start off with the BMS. How detailed is the information when it comes to determining a bad cell/module?
Sure, Chris, that's a very good question here. So we monitoring each cell's voltage, amperage, and temperature, and we record those information. So you'll be able to log in and see that if there's what caused the problem. Maybe it's high voltage of individual cell, or maybe there's some spots that a high temperature. Maybe it's related BMS issue. That means the electronic may fail to track the right information, or it could be individual cell that are just not sorted well. So it will give you that level of information to determine it's on the problem on the BMS level, on the cell level.
Chris also wants to know, what is the lowest ambient temperature it can still operate at?
The lowest ambient temperature for LFP chemistry, you can discharge the battery up to down to -4 Fahrenheit, which is -20 degrees. But in terms of the charging, you really want to charge the battery above the freezing temperature. So frozen temperature, and is the lowest you want to go.
Next question. The presentation states eFlex 5.4 as 15.4 kilowatt hours. Is this correct?
That's not correct. It should be 5.4 kilowatt hour. So I will go back, take a look at that.
Okay. Thank you for bringing that to our attention, Robbie. All right. Next question. What is the upper temperature limit recommendations in the LFP5 in NEMA enclosures suitable for use on the roof?
It's 140 Fahrenheit, 65 degree. You do not want to go over that. But again, if you in that cases, for this type of applications, you can get a NEMA 3R rated enclosure with the fan or basically heat disperse. Yeah.
All right. Next question. Is there a BMS that controls all systems in parallel?
Yeah.
If max discharge is to 20% of capacity, what is the max charge in percent of capacity in regular use?
Well, the maximum discharge, you can do less. Like I said, commonly in a off-grid or if you need a time of use self-supply, you need a minute cycles, you will set up 90% of the discharge. So you will keep the remaining 10%. No, I'm sorry, 20%. But if you just do battery backup and you don't need that many cycles, we really suggest you can go, as low as 10%. And occasionally, if you even more than 10% go to 0%, it's not going to be that a problem. The problem is that if you constantly discharge the battery 100%, that's why you're going to really shorten the lifespan.
Next question. Do you have an energy management system that controls inverters, batteries, generators, and solar and off-grid systems?
Yeah. Well, the hybrid inverter, both the Schneider and Thor, they actually manage and balance the production and demand between the battery, generator, and solar. So it's already built in. You don't need any additional energy management systems. But if you talk about demand curtailment, which, the 15 minutes interval data, or interval, where the utility is going to measure your loads and determine what's the highest number in the 30 days time period, that's why you need an energy management system that actually can, basically measure your current load constantly and help you also communicate with the grid and help you to lower the demand charge. And we do have a third party that we work with offers that energy management systems.
Next question. When will the eFlex 5.4 battery system be available?
It's going to be Q2. We'll expect April or May time window. We will keep you guys posted.
Next, what applications options do you have for marine energy storage?
For marine, we know that for marine, assigned nodes mainly 12 and 24 volts. We do have a 24 volt 5 kilowatt hour battery bank that are, we do have some distributors carry them for certain markets in the Latin American market. So if you're interested in that, we can certainly, send you information about that. And I think that it's named for Pat.
Yep.
So I think, we can send information. We'll send information to you, Pat.
I'll mark that down. Next question. Is a calculator for usage you showed at the end available anywhere?
Yeah. Well, this is something we offer to our dealer or authorized installers. So once you sign up, you can get that tool. And again, if you get a chance to take a look at our dealer form, there's no bonding commitment says you have to buy. This is when you sign up, we know who you are. We can verify that you have enough experience with the solar, and then we feel comfortable, to train you and then sign and have you to install the system. We do also get a lot of leads. We, also send it back to our dealers as well.
All right. For a backup generator option, do you recommend a DC generator system, 48 volt, or an AC generator off-grid situation?
For backup, okay, you mean generator here. Typically, I've seen the generators on the AC side because you have a gen input, there's an AC input. You can use a 48. I have we don't have too much experience with a DC generator, to be honest. I know that you can use a charge controller, 48 volts charge controller, take from the grid to charge your battery. But commonly, system we see operate with AC generator.
Okay. Is the BMS built into the battery, or is there a need for communication between the battery and inverter or charge controller?
It is built in. There's no, you don't need any additional equipment for that. Let's put it down here. I think we have a lot of questions here.
Yeah, we do.
Okay.
Okay. What are the pros and cons of each, and do you support a DC generator such as a Kohler DC genset?
That's a good question. Like I mentioned earlier, personally, I do not have too much experience with a DC, with a DC generator. So, Todd, this is something I will have to dig into and get back to you.
Let me see where we at. Pros and cons. Okay. If we have other inverters that is not on your list, will that be compatible?
You can send us the information, the data sheet, and contact and manufacturer, and we can verify that.
All right. What is your advantage to have closed loop communication with some specific inverters? Won't that reduce your market share as intended buyers might have other inverters?
Well, that's a very good question, James. The way the BMS actually works is you can use closed loop or open loop in a sense like eVault, eFlex. If there's inverter that does not require communication like Radiant, Outback Radiant, you can use them just by setting up the parameters. But if you use, Stark, Schneider XW Pro, then we can, you can use a cable, IS-45 cable connect inverter and battery. That way, the BMS can report SOC. So it works with a closed or open loop. So it gives, flexibility.
Next question, is your distributor training online?
Yeah, we can do online. I mean, depends where you are. We also go to our distributors. We do some set up training for the employees as well for their clients, their installers.
All right. In the case of the SolarArc 12K, if the DC generator, then the smart load becomes available for smart loads.
Todd, again, I have to get back to you about that. I have to dig into that.
All right. If during system maintenance, the battery is disconnected for more than an hour or so, is it necessary to use a power resistor to control the inrush current of the inverter and protect the BMS?
That the inverter, first of all, the battery itself can handle a rush current from the inverter. Now, I'm trying to understand the question is that if half hour or so, if during system maintenance. Now, it depends on what where you're going to do what problem you have. If you work on the inverter side, this days inverter has all pass through, so you can put on pass through. So the PV is still going to send power to the grid, and you can work on the inverter. And if you are talking about, the concern of the irrush current that caused by the inverter, the battery is designed to can handle irrush current, which is, it's very high. It's about, 1,800 amps, but it's very short time period, few milliseconds. So or even milliseconds. So it's already designed to handle that. I hope I answered your question. If not, then you're welcome to, send me a separate email. We can discuss offline.
Okay. Is there any training for installers? Yeah,
we have our next webinar training is more really for in-depth design, the lithium batteries and how you install the systems and make sure you get, the best performance.
All right. Last question. Is it recommended to connect RS485 communication to the SolarArc 8K to display proper SOC, state of charge?
Yes, once that communication is established with SolarArc, you can certainly do that, but it will require, you do a firmware update on the eVault units you get. I assume you have an eVault with a 5 of 10 that we do not have the communication, so they will not apply. I believe we did miss one question here. I want to make sure we answer that last question here. It's from Christoph.
Okay.
When you calculate cost per kilowatt hour, are you evaluating that cost using throughput power? Correct. Yes, we're using the energy throughput power. So if you look into, some other manufacturers like Tesla or LG Chem, they use a guaranteed energy throughput in megawatt hour, and that's and that's actually how we use the same methodology to calculate the cost per kilowatt hour, to calculate energy throughput and out-of-pocket cost divide energy throughput, and that will be the cost per kilowatt hour. I think we went through all the questions we have here. There's a lot of good questions.
Okay, great.
Good. Well, thank you so much for joining the webinar, and apologize again for the people that cannot aren't here because we are limited to certain it's limited to certain capacity. But again, we will send the presentation slides in the next day or two. And if any of you have questions, feel free to contact either me or Andrew or sales at Fortress Power. So we will make sure to get back to you with any question and support that you need.
Great. I think that wraps it up. Thanks everyone for attending. If you have any questions, feel free to contact us. Thanks.
Thank you.
Bye.
Bye.